Okay? So this is to the third power, so how many coefficients do I need? 4, right? So if I go back to Pascal's triangle, so we need 4, so it's 1, 3, 3, 1. So let's carry those forward. 1, 3, 3, 1. Those are the binomial coefficients. They're not necessarily the coefficients at the end. Once we simplify, there could be more things involved, right? But the binomial coefficients are 1, 3, 3, 1. Okay, now notice that this time the first term is actually squared itself, right? So I got to be careful about this. I'm going to say the first term is x squared to the third plus x squared squared 4 to the first. Right? Take this, the first term should have that raised to the third power. And then the next term will have it raised to the second power, and then it'll have the second one raised to the first power. And then the next one will be x squared to the first, and 4 squared, and then the last one will be 4 to the third. And then we got to stick in our binomial coefficients, 1, 3, 3, and 1. And then simplify, right? What is x squared to the third power is? No. When you raise a power to a power, what x to the 6th, you multiply. Properties of exponents. X to the 6th. Okay? X squared squared is x to the 4th. You got a 3 times 4, so 12x to the 4th. What will the next term be? (48) x squared, right? You can't multiply 3 times 4. 4 is squared, 3 is not, right? So you have to say 3 times 4 squared, 3 times 16, 48. Right? And then the last one is 64. Okay? So when you have something raised to a power inside, right, then it's going to make these not have that pattern of just like every one is 1 less, because that's squared itself. It's making 6, 4, 2, 0.